All right. Just like Bill O'Reilly says, let's do it live. All right. Just like
No.
Bill.
Okay.
Okay.
That's
Uh,
only half the quote, but yeah.
well, that's the class ready version of the quote.
Dun, dun.
So anyway, uh, let me turn
We're
myself
double
down so that I am. I think
we're two manning the broadcast today.
that's
We get
right.
get double the professor fun. We're gonna be riffing and bantering. Are you excited for our banter, Eric?
Yeah, I think you're really quiet. Can you turn yourself up? You're at 100% in terms of my volume, but let me see if I can turn you up a little bit. Oh, maybe I can turn. I'll do this.
Can you turn me up in the Discord?
I'm doing that right now.
Okay. It seems like it's like normal for me.
All right. Well, I think I've adjusted it so we're about the same volume, so one does not overpower the other.
Okay. I can do should I just do my like NPR voice?
No.
Welcome. Welcome to CMSC 201. Today we're going to be talking about sorting and probably other stuff that's completely irrelevant. Excellent.
Okay.
All right. Yes.
So let's start
Sorting.
on sorting then, right?
So what's sorting? What is that about?
Well, I guess if you have some kind of list,
Mm-hmm.
uh, and you want to put them in order, right?
Uh-huh.
That's what sorting is. It's an algorithm which takes a list that's out of order and puts it in order.
What if the list is already in order?
I'm not sure what happens in that
Does it
case.
explode? Does it give
It
up and go home?
it could possibly.
That was a
Um,
that was on my driver's ed exam. One of the options for they're like, if it's icy conditions, one of the multiple choice options was give up and go home. Like how? Anyway,
hmm.
yeah. So
Let's make a
what do we
list.
put in the list?
6.
Just six. I like
Well,
that.
there we are. All right. Let's see. Is
Can
this
you
is this big enough?
sort it?
Should we make this bigger? Let's make this bigger. I feel like it should
Yeah,
be bigger.
big in it.
Yeah.
Yeah.
Okay. That's big enough. I think. Right? Can you see it
Yeah.
well enough?
Well, I should you maybe you should like directly because I'm delayed on the streamables. No,
Oh.
I'll just look at the delay. It'll
Well,
be fine.
I don't care if you. Anyway.
It's
So.
very big. It's good. It's good.
Okay. So this is some kind of list, right?
Mhm.
And we want to sort it. So what we're gonna do is we're gonna do this. Some kind of list dot sort. And then we're gonna print it out, and that's the end of the lecture.
It's a good
Cool.
lecture. I think we really nailed this one.
I mean, A plus. Uh,
Yeah, it's a very efficient lecture.
yeah. So
Uh,
you see that Python has an inbuilt sorting algorithm. Uh, Ben, do you know what the inbuilt sorting algorithm in Python is called?
is it merge sort?
It is actually a version of merge sort. You're right, but it has its own silly name.
It's like some, isn't it like a state? Well, is merge sort stable?
Uh,
Do we know?
stable. I
Stable
think
meaning
I
like
think their version. Well, so their version of is two
is it a?
algorithms mixed together. It's
Oh, okay.
insertion sort and merge sort mixed together.
It's a sorting cocktail.
That's right. And
Okay.
they've named it Tim sort.
Oh, Tim sort. I've
Yeah.
heard of that. Yeah. Cool.
Okay. So, what the heck did Python just do here, right? It sorted the list, which is what we kind of wanted, but we don't really have any understanding of how it was doing that, right? So, let's try to write ourselves a little algorithm that might actually do this process for us. Like, we want this to be done by us now. And so, how are we going to do that, right? Why don't we write like a simple version of bubble sort, maybe?
Yeah, let's do it.
Yeah, let's do that. So here's like the I'm gonna call it primitive sort,
Or like,
and it's
yeah.
going to take the list.
So I think, in my infinite knowledge and wisdom, that
Yeah.
all we need to do is just loop through the list and swap any pair of numbers that's out of order, and I think we'll be done. Like, definitely done. It will totally work
Oh wait, so
100%.
you're saying one loop?
One loop. That'll
For
work,
I in
right?
range,
That's totally
len
gonna work.
the list. Okay, let's try that. And then let me steal a swap function. So I'm gonna make a little helper function here called swap, and it's going to take a list. And it's going to take x and y, and then we're gonna swap the elements at x, y. So temp equals a list x, a list x.
Wow, you took like a common
Y.
function that's kind of small that would be useful in a lot of places and put it out to the side. You're very fancy.
In fact, this is planned. It is not an accident.
It's not
what is happening is not a mistake.
Oh.
You do not need to adjust your screens.
Okay, I was adjusting it.
Okay. So this is Bensort. And what Bensort does,
and it's a very good sort. It definitely works all the way.
well, so if the list I is less than the list I plus 1, then what we're going to do is we're going to swap the list I and I plus 1, right?
Yeah.
Maybe return the list. But really we don't have to, because it's going to, because lists are, what's the word for it, Ben?
They're immutable.
Oh, well, I would just, I don't usually pronounce the silent H.
Yeah, that's because you're very French.
Yeah. But yes, they are mutable, in fact. So
they're immutable.
So, okay, let's, now that we've said all of those irrelevant things, let's invoke Bensort.
Yeah.
And see what happens to our some kind of list.
It's definitely going to work.
And print it out, because that's what we do. Okay. Cool, so we haven't made any modifications to the some kind of list. I think everything is right. Let's hit go.
Let's go.
Ooh, nice. What happened? Index error. So so this was an intentional thing that I did. When you are accessing the element at position I and the position I plus 1, can you go up to the length of the list? Generally not, right?
I know. Yeah, it feels uncomfortable.
Yeah, it's a little dangerous, right?
Yeah.
Because if you do that, then you're going to get an index error, because everything's going to be cool, right? We're very cool and very legal until very cool. I mean,
excessively cool.
infinitely legal until the very last cycle, right, of the of this loop. At which point we have to we'll access the length -1 and then the length of the list, which is not inside of the list. So let's try this again with that little fix made.
And now it's going to work completely.
Oh yeah, it definitely worked. Okay, what happened?
Oh, that looks sorted. I think we're done, right?
Yeah, I think so.
Wait, it didn't even work.
It didn't even.
It didn't even work in the not work way.
So, is there something wrong with the swap function? Let's debug. It looks pretty right to me, right? I'm trying to.
Oh, honey child. Let's line 9. You need greater than rather than less than. You only swap if the one is bigger than the one behind.
Okay, I'm convinced.
We did it. See, everybody writes bugs. Sorted by Ben Arithmetic. Welcome to Ben Science. Where close enough is fine. Don't let be perfect be the enemy of good. Hey, that's sorted. I'm happy.
Okay, so what did this do, and what did it not do?
I mean, 9's in the right
actually
spot.
It did very little of things. Well, 9's in the right spot, but 9 was already in the right spot. So let's
7 is in the right spot.
Let's put 9 here and run it again.
Okay.
Okay. Look at what it has done. So what it's done is it's cycled through the list, right? And it's taken this element and it's kind of transported it. It's swapped it with the 6, then it's swapped it with the 3, then it's swapped it with the 2, and then it's swapped it with the 7. In fact, we can even print out every time it swaps, we can just print out the list, so I don't even have to say any of these words. We can just see exactly what happens.
Yeah.
There we go. So it swapped it with the 6, then it swapped it with the 3, then it swapped it with the 2, and the 7, and the 1, and then this is just the final print, right?
You know what it's like that 9 is doing? You know how I would like metaphoralize?
Well, I would call it percolating.
Yeah. It's definitely, it's like if you release a little bit of a gas into a fluid, it sort
Hmm.
of gets this behavior where it's less dense than the fluid it's in, and it percolates. It
Carbonation.
levitates. Yeah.
Carbonation sort. Okay.
Carbonation. Yeah. I like it.
Okay, so
Call it
what?
carbonation too.
So
But look,
basically, in order to fix up Ben's sort, let's fix up Ben's sort a little bit. So, what was the problem with Ben's sort? So the problem with Ben's sort is that it didn't actually it sorted one thing into the proper position, but we need to kind of invoke this multiple times,
put it
right?
in a for loop. Let's just
Okay,
do them all.
let's do that again. So
Just do
for
all of them. Just do them all. Just put it in another for loop. That'll be great.
yeah, let's just have it do it a whole bunch of times.
Yeah. Let's just twist its arm and say, "Hey, look, kid, you're gonna get sorted."
I mean,
Over and over. So,
you
because
think-
if we beamed up,
yeah.
in fact, this is the code they used in the '60s original Star Trek for the beaming up. You guys didn't even know, but that's what this is. But yeah, so it's gonna beam up 9, and then when it runs again, it's gonna beam up 7.
Actually, selection
beam
sort.
up
Selection
6.
sort is beam me up sort. But
Oh, okay.
anyway,
Yeah, you're right. It is actually beam me. You're right.
the problem with Ben here is that he's not a Trekkie like I am. So
It's true. I'm not as Trekkie. You're super Trekkie.
all right,
You're
let's
super
hit the
everything.
play
Let's
button.
do it.
It's time.
Let's go.
Okay. All right. So we see that at this point we have finally written ourselves a sort.
Oh,
So are we
it's
done?
done a lot.
Like we're done learning about sorts, right? Because that's all there is to it. Just if the thing sorts a list,
Then we're done.
then we must be done. So
Yeah.
okay, so clearly the answer is well, not quite. And so why not, Ben? What could be a potential problem with this
Well, is it good at parties? Like, is it fun at parties?
um
You think this is fun at parties? Like, if you're like, hey guys, check it out, I can swap things.
well, I
people
think
would
I
really
think
like
this
that.
sort would be fun at parties.
Yeah, I think so.
But
Percolation sort.
yeah, percolation
well,
sort.
the thing is, we're maybe doing a little too much percolation, right? Because we're doing it n times, where n's the length of the list.
Yeah, let's have some other list.
Like, it could be less.
And let's
We
say
could
that
do
this
it
other
less.
list is actually just sorted, right? And then we're going to
Yeah.
look and see what happens when we run it on this.
You have to move your print statement, though, or it won't print anything.
Hang on. Will
Your
it
print's
now?
inside of the swap. Put it outside the swapper.
Yeah, there we go. Oh, but then I also want it outside of that, because I don't want it to print n squared over 2 times. Okay.
Yeah.
All right. So here what we see is that this inner for loop, or I should say the outer for loop, runs a bunch of times, and if we move the print statement to the inner for loop is going to run a lot of times, right? And some of this was necessary and some of this wasn't necessary, right? Because if we're done, then we should stop looping, right?
But how do we know we're done?
Well, what we could do is we could invent a little variable called swapped.
Oh.
And what I'm going to do is I'm going to kind of...
to the chat. They're saying that this code would definitely woo the ladies, and I disagree. The ladies got this. They're like, what? Percolate sort? I know about that. That's not exciting. Come on. Oh, please.
So I'm going to make swapped equals true. And then I have to replace this guy. This guy's got to be a while loop. So I'm going to say while swapped. And so what that's going to mean is that while we have gone through the inner loop and had at least one swap that we had to do, if that's the case, then we know that the list was still out of order. If we go through the inner loop and we never do a swap, then what we know is that the list is already in order, so we don't have to do it again, right? So I'm going to set swapped equals true here. And then as soon as I enter the loop, I'm going to set swapped equals false. And the reason why I'm going to do this is because, well, why am I going to do this? Because
every time we want to see if we swap something.
Exactly.
So we got to start it back to false.
Right. So if we enter the loop, we set it to false now, we turn the light switch off. Whenever we make the swap on the inner loop, someone else, the if statement flips it back to on, and then by the time we get out to this while loop here, we know that it's been we know that something's happened this time, right?
Yeah.
So, and then I think the other thing we have to do is kind of mimic the functionality of a for loop here, right? We just have to say like while j is less than when the list, and
They're not. The chat is yesterday when I did this. The chat got enraged, incensed, even that the outer loop used J instead of the inner loop.
you did a chat yesterday.
I did.
Oh
this,
wait, this is
I did this for
oh,
like
I see.
5
Yes,
minutes at the
I
end of
see. I
yesterday.
see. I see.
So this isn't the first time they've seen.
Oh, okay. I understand. I was
this
like,
this is recap.
ah,
They've already seen percolation sort. But that's
yeah.
okay.
I didn't cover that.
That's great though. This is review and it feels good. So let's do it.
Okay. Well,
I
now what do? We test our code because
let's count. Let's count how many times we do that comparison, that if statement. So you just pop like a little counter in there and be like,
how many times we actually check the if statement, or how many times it's true.
how many times we check it. So before the if statement, we say like +1 to some count variable, like the count.
And why do we not print the list now? Because that's just gonna give us a huge amount of vomit.
Vomitation.
Yeah.
Yeah.
All right, cool. Let's run it and see what happens.
Let's
There's always a question of will it work when you're live coding, and the answer is 30%.
Yeah. Will it blend?
Well, so it's sorted a sorted list.
Yeah.
So hey, great.
Cool. And it only did 4 comparisons.
Yeah, it only did 4 comparisons.
Right. What if we sort the unsorted list? How many comparisons?
Yeah, that's a better question, right? Because
will it do more? Will it do more? I think it might.
Well, I hope so.
Yeah. Otherwise, we have problems.
Well, so this list is also bigger, so let's remove the 1. It's unfair. It's not fair when you're competing against a smaller list, right? It's like they get a head start.
So what if we took out that swapped thing?
Well, right? You mean just never bother to check it, just let it be true?
Never switch it to false.
Well, in that case, what would it be? This is equivalent to the...
should go up. It should go up, right? Our number of deals.
Oh, the number of... Yeah, of course. I mean...
Because we're not stopping early.
Yeah. So it saved us how many? It saved us about 4 iterations through this.
It's pretty good.
Crap, really. But...
Oh my gosh.
But on the other hand, it's better than nothing, and whatever.
Yeah.
Okay. So
I like this one, but I want to hear about this beaming up sort.
You want to talk about insertion sort? Or no, selection sort.
Selection sort.
Okay, let's do selection sort now.
Let's do that one. Yeah.
So this is one idea of how to do sorting, right? This is one idea that just says go through the list and check if you need to swap each individual element with the next element, and then swap it. But let's see if we can kind of short-circuit this a little bit. Basically, so I'm going to define a selection sort, and it's also going to take a list.
Beam sort? Let's call it beam sort.
Okay, well, I'll call it selection sort because that's kind of what it's... So, incidentally, Ben sort has now become bubble sort.
Oh, that's true. It's bubble. Oh, that's a much more succinct name than percolation sort. You're quite the wordsmith.
Okay, so how about selection sort? Well, what's the idea of selection sort? The idea of selection sort is basically that it is going to search through the list and pick the element that should go into the first position, the smallest element. So it's going to run a find min operation. Once it finds the minimum, it's going to swap. Then it's going to run through the list again from the second element to the end and do a find min and then swap. And it's going to do that until all humans are eaten.
What?
So, let's do an example. Let's actually demonstrate what's going on there. Let's make the list a little bit, let's just make it, this is fine. Let's hit go.
Go, go, go.
So, unfortunately, well, no, actually, the minimum is 3 here. So I pointed at 2, and then I said 3. The minimum is 2. And so it's going to swap 2 with 3. Cool. Then it starts at 44, which is the second element. Tries to find the min. The min is going to be 3 in this case. Searches to the end. Swaps. Searching. It's looking for 4, right? It doesn't know what it's looking for, but it's found it. Okay, now it can swap. Here, it doesn't know if 5 is the minimum, so it still has to do a find min. It has to search for the minimum, and now it doesn't swap. Here, searches for the minimum. It's found it almost right off the bat, but it doesn't know, so then it swaps, etc. And so here, it'll look for 19, I guess. Yep, and then swap. And, as it turns out, we will now accelerate this because that part of the explanation is complete.
Yeah, so to answer some chatty chat questions, selection sort looks for it's looking for the min for each, to figure out each position. So it's figuring out what goes in the first slot. Well, that'll be the smallest number. What goes in the second slot? Well, that's the smallest number of the things that I haven't already looked at. And then what goes into the third slot? And then you look for the next smallest item, and so on and so forth. So if you had a bunch of numbers in front of you on a table, selection sort would be like looking over them to find the smallest one, putting that in a list, and then looking through and finding the second smallest one, putting that in the list, and kind of rebuilding the list. But we can do it in place because we can just swap. We can do that swap-a-roodle.
Well, I mean, bubble sort was in place too, so we don't have a distinction yet.
That's true. We don't have any not in place sorts.
Yeah.
Yet.
What's a non in place sort? I don't even know what you're talking about. All right. So let's code it up. So basically here, what we're going to do is we're going to do for I in range len the list. And so what this is going to do is it's going to say we need to search for the minimum from position I basically until the end of the list. So I'll just denote that as a little slice notation because everybody likes slices and it never confuses anyone. So
I know,
right? So anyway, now what we need to do is implement a find min operation. There we go. How do we implement a find min?
Comment. That's probably good enough, right?
Oh yeah, no, I wish that like you could just tell Python, you could be like, search. That would be beautiful if you could just write those 2 English sentences, and that would completely. I mean, it does completely describe the algorithm we're about to write.
Yeah, I mean, it does. There is a built-in min function, but that is a forbidden magic.
What?
So.
I don't know what that means. I don't know how this would work. So,
also, someone has asked if this is a stupid online class. No, it's not a stupid online class. It's an extremely stupid online class. Thank you very much.
I don't know. Is it really online? What is the internet really?
Is this the internet that we're on right now? I mean, it feels funny. It's kind of tingly.
Okay. So the min is going to be the list at I, and why is it that? Because by the time we get to position I, the rest of the list from position 0 to I-1 will already be sorted. And so we don't want to consider anything before position I. So now we're going to say for j in range. And then here we're going to have to say I up to the length of the list. Actually, if we're even braver, we can just say I plus 1 since we've already set it to I. And then what are we going to do?
That's incredible bravery, by the way.
I mean, it's slight bravery.
So if it's not the min, so we said it was the min, but it's not actually the min.
Yeah, what if the min is a lie?
What if the min is a lie?
So that would mean that the min, and try to make sure that you double check, debug my greater and less than statements, because I've always had trouble with those. Right and left and greater and less than have always confused me. So if the min is bigger than the thing at the list j, then what do we know? So
that the min is a liar.
Right, because if the min is too big, then what we know is that the min is not actually the min, so we need to replace it. Or, I'm sorry. There we go. Replace it with the list j. So let's do that. There we go. All right. Michael from Vsauce? Well, if you're into that kind of thing, I guess. So...
But don't we also have to remember where we found them in if we're going to do a swap-a-roodle?
Ah, yeah, so, I always forget about that.
I do too. I just now remembered it.
Oh, no, it's not the min index, it's just min index equals j. Okay. I think so there's a reason why I usually actually just code these up before class, because then I'm always like, if I'm explaining them and also typing them, it's a problem.
Oh, no, I always make mistakes. It's great. I love it.
I don't particularly, but whatever.
I know. It's an acquired taste.
Yeah, I mean...
I had a little bit of a hissy fit with the iterative Fibonacci solution.
What?
It got eliminated.
How can you... never mind. Also, I can hear a reflection from your audio.
Oh, no.
Oh,
okay.
No.
Oh, no. Okay, maybe that'll be better.
Anyway, so can I just call swap, or do I need to check something? Oh, goodbye, Ben. Okay, so do I need to check something? The answer is, technically, if you're afraid, yes, but really no, because...
Did I go bye-bye? Am I still...
You're here again.
Okay, good. Whew.
So anyway, do you need to check? Or can you just call swap? So what's the lazy solution? The lazy solution is not to check. But technically we can always just say if I is not equal to min index, if we're not lazy.
I'm gonna grab headphones. I'll be right back. I believe in you.
Oh, well, I mean, okay. Alright, anyway. So then at the end of this, we're just going to return the list. And now, of course, we want to check. We want to see, you know, if this thing works. So let's sort this list. Okay. If I is not equal to min index, then swap min index. Why is it not doing anything? That's a good question. The min index is bigger than the list at j. Then we have that. Really, we don't even need.
I'm back. Did we win?
No, we lost horribly.
We lost horribly?
Yeah.
Oh, no.
Yeah, we lost horribly. I'm gonna delete this and fix this a little bit now that we don't need that. But yeah, it didn't even... Oh, wait a second. I didn't pay attention to my tabbing.
Oh.
Yep, there we go.
That would have made it go all.
Yeah, I was a little confused. I was like, how have I screwed this up? I can't believe it. Yeah, so as it turns out, I should have just been lazy and not checked. I think what the problem was I was lining it up with this for loop instead of the outer for loop, if you know what I mean, because like the text is so big I couldn't see it. But anyway, now that
we did it though, we won.
Well, let's not oversell it. We have sorted one list.
We gotta sort more.
So yeah, we should sort more. So let me steal a little function that I wrote. Let's see if and stick it somewhere where no one can see it. Because all things are equal in the eyes of Morbo. Alright, cool. So now let's run a time test. Let's see if we can race them.
Race!
Yeah. That's fun, right?
Yeah.
Let's bubble sort.
There's so much forbidden magic happening there. But no one sees that.
Well, exactly. That's the whole point.
This isn't the code you're looking for.
Well, right, exactly. Let's run 3 tests, and let's run them on, say, I don't know, lists of size 1,000. And let's hit enter.
We're racing. He's asking in chat, what are we doing? We're racing. This is pod racing, guys.
Yeah, I know, right?
We're taking the 2 sorts and we're seeing which one's fast.
So we notice here, sort 1 is bubble sort, sort 2 is selection sort. Look at that. It generates, so what this code does is it'll generate 3 lists of size 1,000, and those lists are randomized, and then it races them on the algorithm. And so we see here that bubble sort, if we thought the bubble sort was the end-all be-all sort because it works, right, then selection sort has just taught us a lesson. And that lesson is selection sort is usually faster, right? And we see that here in these 3 examples. Here it's running in about 0.18 seconds, and here it's running in about 0.03 seconds. And so that's clearly a lot faster.
Shouldn't bubble sort be faster
than selection sort?
Yeah. Because bubble sort occasionally will finish early. We may not have fully optimized our bubble station.
I think if you have a random enough list, selection sort might do better because they generally have to go through the whole list, and also the selection doesn't have to swap every time, whereas bubble has to do a whole lot of swapping. So it's like a multiplier in the number of operations, right?
Yeah, it's a constant time thing.
That's right. I believe so.
What if we did like 100,000?
Okay, well, let's run a test on 100. That's 100,000. I don't know if it'll finish in our lifetimes, but we'll see.
No, it'll take a little bit, right?
Well, so the expected number of operations is about 1 million per second, right?
Yeah.
For the average computer. And then 100,000 squared is what?
A lot.
That's like, and then we divide it by 1 million.
Yeah, and we end up with
10,000 seconds.
That's a number of seconds.
So why the heck did you suggest this? Other than, did you want it to not terminate?
Well, I just wanted to show these could be very slow if you have.
Oh, okay, good. Okay, excellent. I am very happy because
we should write a sort that's very quick.
You want to write a quicker sort?
I want to write a quicker sort, possibly even a quick sort.
Okay.
Wouldn't
Fair
that
enough.
Be crazy, huh?
Yeah, let's do it. Let's kill this now, because I don't think this is going to terminate. Well, so it'll terminate within our lifetimes.
Yeah.
Oh, you know what? It would only take 2 hours. 2.7 hours.
Yeah.
So it's fine, right? No problem.
Yeah, we got time. We can sit here and talk about how secretly insidious Fraggle Rock was. I'm just kidding. I'm just making up stuff. All right, no. Let's do quickly sorting.
Is this how your classes usually go?
Mm-hmm.
Good God.
You know what we need here? You know what I'm missing? You know what everybody has crying? All the students, they email me, they send me Discord messages, and they say, Dr. Johnson, I really miss recursion. I loved recursion. It was my favorite thing. I loved homework 6. I wrote all of my friends and relatives about what a good time I had on it. And they want more recursion. So I say we give them more recursion.
All right.
Prepare
for recursive process.
I feel like we should have one of those like 90s cartoon sequences where we're like sliding through a tube of lights and we're about to go into a giant robot of sorting. All right, let's do it.
Yeah, I'm like, I was about to look up some kind of YouTube video while you were blathering. But instead of all of that, let us just do an example of Quicksort. Here is a list, and let's... Okay, shut up, I don't care.
What's our strat? What's our strat before we start?
No. We have no strategy. We have no strategy.
We need a strat.
I don't know.
We need to build. We need to figure this out before we just jump in there, right? What are we going to do?
Nah, let's just watch it. Let's watch it the first time.
All right.
Let's watch it the first time, and then we'll come up with a strategy, and then we'll talk about how it worked.
All right, I like it.
Let's just watch what it does. So, like, what the heck is it doing? Who knows? That's crazy, right?
There's so many colors.
All right.
Woo.
What's it doing now? So it's looking at 5, and it's saying, okay, cool. I like that.
You know what I think it's doing?
What do you think it's doing, man?
I think it goes through and it looks at each value and it tries to figure out where that value belongs in the list. So before we would look at the first slot and we'd say which value belongs in the first slot. Now we look at the thing in the first slot and we say, where's your home? Where do you belong? And that's what we do. I think that's what the colors do.
Wasn't that more describing selection sort?
No, because selection sort is I want to find the thing that belongs in the slot. And this is more, I have the thing in the first slot. I want to figure out where it's sorted list.
Huh.
Yeah. You know what I mean?
No.
No. Yeah, sure. So I think what it does is it finds all the values smaller than that number, and then all the values larger than the number, and it puts them on either side of it. Let's do it again. Let's test our hypothesis.
Let's do it with a smaller. Well, okay, that's garbage. Let's try again. Let's do it this way. So I think I understand what you're trying to say. Oh,
good. Whew.
So here's the basic idea. The way I'm interpreting Quicksort. You take the first element in the list, this 3, right? And then you go through the list and you ask the question, who is smaller than me and who is bigger than me?
Yeah.
Right?
Who are the smallies and the biggies? And I want to find out who they are. And if I put all of my smallies on my left, then I have found my proper home. Yay.
Ah, yes, that is okay. That is the after effect of Quicksort. Yes. Sure. Okay. Yeah. Let's run it.
Let's do it.
So here it sees 2, and there it sees 1, and then that was very fast. So what did it just do? Let's go back. That was like the whole sort. So, oh wait, we can slow it down. Let's slow it down. So first it looks at the 5. Okay, maybe not that slow. Okay, that is more. Okay, that is very slow. So first it looks at the 5 and it says 5 is bigger than me. Then it looks at the 2 and says 2 is not bigger than me. So it swaps it into the position next to it. And then it sees, okay, I couldn't even say it that fast yet. So, yep, okay.
It finds all the green ones, which are less than it, and it finds all the purple ones, which are bigger, and then it puts the purple ones on the right and the green ones on the left.
Yeah, so this is an in place.
This is this one. Yeah, this one's in place. This is tricky. We could do it.
We should do it. Let's do a not in place version of the sort.
Yeah, I like that idea.
Because it actually does make it a bit easier to conceptualize.
Yeah.
So, and then once you understand the not in place sort, you can go back and kind of retcon your way into an in place sort. So, Let me explain what we're going to do. This is what we're going to do. Here's the plan of attack.
So we're going to make 2 lists, right?
Actually, I'm going to make 3.
Whoa, 3 lists. You're a madman.
Yeah, I'm going to make a less list. I'm going to make an equal list. And I'm going to make a greater list.
Oh, wow, yeah.
I mean, there's multiple ways to sort of quick.
Yeah, you can. Yeah.
So, anyway, this is just randomly what I'm choosing to do, And then what I'm going to do is I'm going to run through the list. I'm going to say for x in the list, right? And then there's a fun word in math that no one likes. Actually, I don't think anyone really hates this word. Just no one knows it. It's trichotomy, right?
Ooh.
Trichotomy.
Well,
right?
Isn't that like a dichotomy that leveled
It's
up?
like a dichotomy. It is exactly like a dichotomy. And what's a dichotomy, Ben?
A dichotomy is a split of things into two.
Yes. You must go right or you must go left. So a
Yeah.
trichotomy.
That's when you add another tube to the water park slide.
That's right. So
Yep.
anyway, if so what we're going to do, let's just be lazy and do that.
Mm-hmm.
And then let's say we have to name an element.
Jeff. Tanya.
Oh, okay. Actually, let's not even do this. Let's just say Jeff the pivot is equal to the list at 0. Right? Yes?
Yeah.
Okay.
Yeah.
So
That's as good a place as any.
if x is going to be less than Jeff the pivot, then x goes into the less list.
Important question from chat. Is there a quadrichotomy? I bet it's like
Of course there is.
Is it like a tetronomy or a...
Oh, I think it would probably be like a tetrotomy or something.
Yeah.
What's that thing? So if you have like 4 people in charge of a country, it's a tetrarchy, right?
Mm-hmm.
So I think it would be like a tetrotomy.
Aren't these like Greek prefixes or something?
Yes.
Why is that funny? Okay.
So it's funny because you see, Latin has imported so much of the Greek that it's hard to tell exactly where things are imported from. But yes, most of it is Greek. So if it's equal, then we put it into the equal list. And then else, and this is the nice thing, trichotomy guarantees we don't have to check anything here.
Yep. It just goes into the list of the big stuff.
Yep.
So we made 3 lists. Everything. So we've got Jeff the pivot, or Jeff Pivot.
Yeah, that's right.
So then everything that's smaller than Jeff goes into the small list. We picked Jeff because he's just the first guy in the list. It's fine. And then everything that's bigger than Jeff goes in the bigger list, the greater list. And then if you're equal to Jeff, you get into the equal list. I like it.
That's right. And so now what we're going to do, and here's where the recursion comes in. We are going to return a quicksort of the less list plus the equal list plus a quicksort of the greater list. And we're done.
Oh my gosh. And this is what I call the trust fall part of recursion. You just kind of have to just be like, hey, look.
Are you trusting me right now?
Yeah, do we trust our recursion to do its job? We should, because that's how recursion do.
Yet. We should not trust this recursion. Why don't we trust this?
Why not? We don't have a base case.
Oh, that's a slight problem.
Yeah. It'll just go. Actually, it'll give us an error because eventually you'll get an empty list.
An empty list won't. Oh yes, it'll give us an index error.
Because then we have no Jeff.
I know, but that's a good thing. Let's run it on some list.
We've got to remedy our Jefflessness.
Yeah, let's run it on the quicksort. Oh, it's still running because of your traitorous suggestion to the course.
You're using a lot of electricity right now.
Yeah, I mean, I have like 60. You know, my like, ooh, ouch. So index error, right? So what does this tell us? It tells us that the list was probably empty, since if you can't even access the list 0, there was nothing in there. So before we do any of this, we're gonna do something else. If the list, maybe if not the list, right?
Yeah, if there's nothing in the list.
Right, if not the list, then what are we gonna do?
Take a nap? No, if it's an empty list, we're done.
Yeah, we can just, well, I mean, let's return the list.
Because the base case is when we're given a problem so easy that we could just be like, well, the answer is blah.
But we can even be a little more aggressive than that.
Oh my gosh, we could get more aggressively
lazy. We can just say if the length of the list is less than 2, we can just return the list. Now, why is this essentially just as good, right? And actually slightly better. Because if we didn't do this, we would have to have two base cases. We'd have to have the base case for an empty list, and we'd have to have the base case for a single element. Why do we need a base case for a single element, Ben? Drum roll.
We don't.
What?
Yeah, we don't.
I guess eventually it would get to equal list. And you're right. Okay, yeah, I guess eventually it would get to the equal list, the greater list, and the less list.
It keeps us from having to execute all that logic.
Yeah, but it keeps us from having to go through all this extra code, declare 3 extra lists, select the thing, try to go through the for loop, and then return this on 2 empty lists. It basically just saves us a bunch of really, really dumb base cases that we shouldn't really be executing. Yep. Anyway, let's hope this works.
Coin miner. Gosh.
If this works, I'm going to slightly laugh.
Okay, would you call it like a chuckle or a titter or a harumph?
No, I have no idea. Let's run it.
Where's
I didn't print it.
Is it a cachinnation? I forget. Is that the word?
Look at that. You know,
the fall.
So here is proof that we are both essentially the dumbest people in the universe, or I am probably, is that I couldn't write a bubble sort. I couldn't write a selection sort. But somehow I could write a quicksort.
Yeah. Quicksort's actually kind of easy because it's, there's
and
not as
bubble
much
sort's
index.
not? Anyway, let's...
You gotta do that like swap-a-roodle. That's kind of scary. Swap-a-roodles can be swap-a-brutal.
You
I got Natalie choking on water.
If she dies, that's technically murder.
Oh no! No, Natalie, live! Okay.
Anyway, now that we're through that little experience, what should we say? Any questions about how this works, right? Yeah. Any questions about how this is working? So, this thing is going through, the base case is just saying if the list is sufficiently small, i.e. 1 or 0, it just returns the list as is. So if it's a singleton element, it gives you back the list. If it's a null list, if it's an empty list, it gives you back the list. If not, it splits your list into 3 parts. Are sorting algorithms set in stone, or are there undiscovered sorting algorithms that are better? The answer is, there is a theorem that says that there is an upper limit of performance that sorting algorithms can get, but that doesn't say that we have discovered the best one yet. There could be a slightly better algorithm out there that we haven't found, but
there's a theoretical best.
Yeah, but that theoretical best is only good up to a constant, so you could actually improve, right?
Yeah.
It just says that the algorithm has to run an n log n.
Yeah.
Yee.
Let's test. Well, actually, can we run it and then print out the list every time Quicksort is called? That'd be fun.
We could do that if we were on the drugs.
The drugs.
Well, I mean, it is a discrete entity, so let's do it. Let's make this
about like echinacea.
Let's add some more elements to this list so that it's entertaining. And let's run it.
That's an entertaining list, I dare say.
Hell yeah.
Uh-oh. There's 2 2s in there. We're going to test our equalness.
Okay, so first it said the pivot was 9.
That sounds right.
I think so.
Yeah.
And then it says the pivot is 6. So what did it do here? Oh, because the greater list only has 1 element, so it didn't actually No good. No good.
Goodsies. No goodsies.
Do it again.
Yeah.
Here we go. That's a little bit better, right? And the reason why I think this is a little bit better is now because the thing is that this being the pivot, it looks through the list, and this goes into the less list, this 3 goes into the less list, this 2 and this 1. Right? Oh, and the 5 and the 4. So that is the less list. But what we see is that the next call to quicksort is on that less list, right? And so then that picks 3 as its pivot. And it doesn't really matter which 3 it is. Who cares? It'll just go through the list and it says 2, 2, and 1 are less than me. And then here, I guess it's, because it's breaking it up into lists that are size 1 and 0 here. I guess it actually break it up into a list of size 1 and a list. And you know what we're going to do? I'm going to move the print statement.
Okay. And after this, we're going to do some pod racing, right?
Yeah, we can race.
Yeah.
Okay, here we see it actually doing a little bit better because here it's picking 6 as the pivot. It's throwing all this stuff into the less list. Then it's picking 3 as the pivot, and it's throwing 2, 2, and 1 into the less list. And then here it picks 2 as the pivot, and it throws 1 into the less list. And then now you see that on one side, there's nothing greater than 2. So here's the greater list, right? Here's the last thing that it does before it starts popping back up the recursion. And here, it's the other side, right? So this is where you have 1 is less than 2. So the only thing in the less list is 1. And then it kind of throws it all back together. So you'll get a 1, 2, 2 here. And then it throws it back into here, except it has to sort the 5 and the 4. And this is where it's sorting 5 and 4. And then this is the other side, right? Where it picks a pivot of 9, the less list is 7, the greater list is 23.
Yup. And this...
Are you saying yes to the idea about the pivot change?
So yeah, you can pick a pivot. You can pick a pivot, like you could pick it randomly, or you could pick it out of the middle of the list. The thing is, if your list is unsorted, no matter where you pick the pivot, you don't have any guarantee about if it's a good pivot or not. Because a bad pivot is bad. A bad pivot would be like the smallest value in the list, because then everything would go into the big list, and you haven't made your problem any smaller, which is sad.
That's right.
Next time we're going to talk about how do we determine, just by looking at the code, just by thinking about the code, how do we determine how fast these lists will run relative to each other? But for now, we're going to resort to experimental tests, which we are also calling pod racing. So we're going to do some pod racing.
I guess pod racing.
Yeah, let's do it. You guys are subpar. Hey, I'm glad we're even being compared to par.
Wait, subpar is good in golf.
Hey! You're an eagle. Subpar at zombie games. Wow, shots fired.
Well, I mean, just because we suck. No, it's not merge sort, it's quicksort. There we go. Alright, let's do it.
We're good at commanding spaceships, though.
Well,
all right.
Against easy computers. All right, let's run 5 tests, and let's run it on a size maybe 100 to start.
Yeah.
Oh Lord, we need to anti-allow it to print that garbage.
Whoa.
Yeah, no, that's garbage. So let's do it again. All right, 5, 100. There we go. Ooh, nice. Look at that.
Nice.
So what we see here is that this sort 2, which is quicksort, performs, in this case, about 3 times better on average. This one performed a heck of a lot better. I guess it was, it's just, I guess, a little bit better than that. So it's in the 10 to the negative 5 range. But, of course, what Ben wants to do now is hawk it up to a larger size of lists. So let's do 3 tests, each on 1,000. Let's start with 1,000. Okay, cool. So here we start to see the breakaway performance of quicksort, right? Because here what we're seeing is that the selection sort is kind of getting, it's like 0.03 seconds. But here, quicksort is still in the 10 to the negative 4 range. Pretty good stuff.
You should give me mod, because they're trolling the chat, and I need to lay down the slow chat. Or the timeouts.
Yeah, let's see. How do I do that?
I think I just say something and then you click on my thing. Hello.
Um. Ah, I see. Okay. Um. Yeah, let's try to figure out how to ban this person. You know, being an idiot is not necessarily a good thing.
Oh, Cam's here. You can promote him as well.
Yeah. Oh,
Once
enable
you get
slow
the
mode.
time.
So first, let's aim. Okay. First thing, got him. And now, oh, that's easy. Okay, nice. Sorry, everybody. Let's find Ben. Where are you, Ben?
I am
Okay, you're now a moderator.
cool.
Excellent. Nah, yeah, I figured it out. I know. Freaking tech issues, right?
Tiki shoes.
Wow. Oh, okay. So I guess we just had our first visit from true idiots. It's good it took this long because otherwise, my God, I would have been. If this was my first lecture, I think I would have just cried.
Oh, don't cry.
Well, you
Thank
know
you.
me. I have, very sensitive emotions.
Mm-hmm.
But like, why
This is
would someone?
because
Here's a real question: why would anyone even waste their time learning about sorts if all they're gonna do is scream obscenities?
yeah, we could be pod racing
Well,
and these
literally, if you didn't have to teach this class or whatever, what would you be doing right now? Gaming? Watching a
yeah
movie? Sitting on
yeah
Netflix? It's probably what half of the people are doing right now.
I'd be I'd be cachinating.
All right. So let's
Oh no,
run.
it's cacinate. Sorry, not cacheate. Oh gosh, I'm gonna learn
Whatever.
lose my word nerd bona fides.
So,
Let's
let's
do
see.
a lot, a big
Let's
number,
do
not 100,000.
10,000. I think is a safe number,
I think
right?
it's pretty safe.
10,000
Yeah,
squared is so 10 to the fourth squared is 10 to the eighth. 10 to the eighth divided by
it's like
that.
100 million. So
Yeah,
it's
so it's
like
gonna
it
take
might take a
about
minute.
2 minutes or so. Let's
Yeah.
see. But that's
Let's
just
do.
for selection sort.
We'll see how much faster Quicksort is.
Oh wow, I was totally wrong. It took 3.49 seconds
Oh, because we were thinking. Oh,
for
anyway, but
selection sort.
look how much faster Quicksort is. It's so fast. It's so much faster, guys.
Yeah, let's try 100,000 and see what happens.
Oh, is
No, we're gonna run 100,000 tests on size 1 because that's smart. Maybe we deserve the trolls.
no, we don't deserve trolls.
Well, okay, so 100,000. So it's 10 times that. So if we expected that one to take 3 seconds, then it would take 100 times 3 seconds. So we'll come back here in 5 minutes.
Yeah. Uh.
So what do you want to do in the meantime, Ben?
Let's see if I have a would you rather queued up. We can double.
Do you actually have a would you rather?
Of course.
Okay.
Hold on, where is it? Oh no. Oh no. Did I? Wait, hold on. Stand by.
317 years. Something like that. Either 317 seconds or 317 years. Help with Project 2? I am certainly not helping with Project 2. I would never do that.
Where is it?
Alright, while he's doing that, let's watch this.
Yeah, cue it up on the WWs.
Which is a quicksort, incidentally. With some weird... I think it's Czechs.
It's Hungarian.
Oh, Hungarians!
Okay, I got the would you rather set up. Should we discuss it while the dance happens?
I'll just turn the dance down a little bit and you can just talk right over them.
All right, here we go. Are you ready? Every time you walk into a room, the room cleans itself. Like Fantasia magic. It's pretty good. Or you can find any object so long as you know that it exists. You can find it and know its location.
But not necessarily obtain it.
Correct. So you could.
What was the first option?
Every time you walk into a room, the room cleans itself.
Oh. Or you have infinite finding abilities.
Yeah, so this is sorting versus searching. This is actually like a topical would you rather.
Wow.
Mm-hmm. So, let's see. Are there any questions in chat, guys?
So I could find God, if someone asks.
You have to know for a fact that they exist.
Oh, ouch!
I mean, I guess that got a little agnostic.
Yeah, I was like, man, you're oh yeah, technically you were skimming agnosticism there.
that statement is agnostic. So cleaning is therapeutic. Oh, you like cleaning? Oh, okay. So the second one.
Yeah, I mean, my whole house is a disaster. But on the other hand, if I could find literally anything, I could be like, where is X object that is worth $1 million? And then I could be like, okay, I will sell it and hire a maid.
Yeah.
You know, there is that strategy.
But yeah, I mean, maids are great, you know. But like anywhere you go would.
Well, I don't need anywhere to be. You know.
That's true. Well, right now we don't need anywhere but our homes.
I mean, all I really need is this office to be slightly cleaner, and then I'm happy.
That's true. That's because you've got, like we were discussing in 203, you don't ever go outside, so you have that tunnel to campus that opens up at your office.
Yeah, I mean, it's kind of like one of those wormholes. So it's like one of those Einstein, Podolsky, Rosen bridges solutions to the, general relativity equations. It's one of those. But we can just say a tunnel.
Oh, so there's a question, where's the nearest undiscovered patch of gold? You have to know for... So you couldn't do that one.
Let's see. Oh yeah, you can answer questions. You can talk. Eric hasn't seen the sun. Yeah, well, the good news is, I don't need the sun to live.
Since the tunnel went down back in 99.
Yeah.
That's like when we met back in 99.
That's about right.
We partied as if it were 1999 back then. Yes, and we all joked about the fantastic technologies that were coming in the year 2000.
Man, we were optimists.
We were.
I was a utopian, man. It's crazy.
Mm-hmm. I thought that technology would bring us soda vending machines in restaurants where you could pick your own custom mix of things and it would mix them for you. So I had a very modest technological hope, and thank heavens it came true, because my life has never been the same. So,
all right.
Did we graduate?
Hang on.
Yes, we did.
We're about to, let me think. Oh, you can keep talking. I'm thinking. It's hard.
Oh, okay.
Thinking is as difficult as possible.
Industrial soda mixing. I like it. I like it. Mr. Dove. Who's looking forward to the singularity in 2045? Well, that's what... So I worked at IBM Watson, and I get a lot of questions like, when's AI taking over? And two of my standard responses was, well, don't make any specific Thanksgiving plans. Was one of my responses, just to mess with people. My other response was, your question shouldn't be when's the AI taking over? It should be, when's the AI taking over? God, we're not doing such a great job ourselves.
So we have just opened up our voting for the Would You Rather.
Oh yeah, we do it. Wow, you really
Well, I told you I had to think for a second.
Oh yeah, I use straw poll. It's faster, but this is good. You're gonna have charts and graphs and things.
Look, my dude. I did this in real time.
No, you're innovating at the speed of business.
Oh my god. Present yourself for mandatory execution.
Okay.
Anyway.
So what are the numbers looking like?
Cool. We got about 29 responses so far, which means half...
Is it a good split? Is it an even split?
Sadly, 90% of people are on my side.
For the object finding?
But now, oh, it's a little tick up. We have some more people who want rooms to clean themselves. Some other slobs like me who whose lives definitely need help. Oh, it's going up now. I see now that I'm advertising it.
It's pretty nice. This reminds me of the Onion video where there's like political candidates that have like a live graph of viewers' opinions. And like one of them says like a random word and it makes the graph spike up, so then everyone else starts saying like Tupperware. It's pretty great. Ooh, the dance is wrapping up.
Yeah, it is. That means the whatchamacallit is approximately going to end. Oh, I think people are trolling us now. Voting for the all rooms clean themselves out option.
Oh.
Unless, of course, who knows? This is democracy on the internet, right? We'd get President, what's his face? Oh, what is that guy's name? Vermin Supreme.
Oh yeah. Got a boot for a hat, this guy. All right, let's talk about searches.
Okay.
We can wrap this
Excellent.
puppy up.
Yeah, exactly. All right.
Oh no, there he is. He kind of looks like my dad, actually. Which is
no comment. Jesus Christ.
Well, my dad doesn't wear a boot on his head, but my dad does kind of look like that.
Okay.
McGee.
So, all right, let's do this. Let's go back to Python.
Let's go back.
I said that a little weirdly. Anyway. Okay. So, do you want to intro searching, or what do you want to talk about, Ben? Do you want to talk about binary searches?
Let's talk about sequential or linear search or whatever you want to call it.
It's boring.
Let's talk about a search. You want to jump straight into binary?
Well, okay, let's implement linear search within 3 seconds.
So what's the searching problem, though? How do we define that?
Well, that's why I asked you if you wanted to intro it, but I'll do it now.
Oh, so I'll intro while you make the types.
Sure.
So say we have some kind of list here with 693 da 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 da. Something you typically want to do is say, well, is 12 in this list, or is bubbles in this list, or whatever, right? You want to know, does a particular list contain a value? Now, the way that we've been doing that thus far is we say, if 12 in some kind of list, right? So that's what we write in our code, and then it will return true if the item's there, false otherwise. So that's a cute, fun little Python thing. But what we're gonna do now, and what our extremely talented and handsome guide is showing us, what in or index, if you use that, the code for that. What does that actually look like when you do in or you do index? So here we have the in. It just says. You're just using in. Okay. No, but what happens when you call in? You scary man.
Well,
let's do it.
Are you throwing it to me?
I'm kicking it back over.
Okay, so a linear search is as simple as possible, right? It just searches through, and if you find the element, right? If the list at I is equal to X, you can return true. If you search through the whole list and you don't find it, return false. That's literally the search problem, right? The search problem is X in the list, right? That's it. And so it should return true if X is in the list and false otherwise.
But what if we're feeling crazy and we actually instead want to return where we found the thing? We could do that
I
too.
suppose you could do that.
We could do that
I mean,
too.
who cares? But that's
What would we return if we didn't find it though?
-1.
Oh, -1 because that's not a valid index. You're very
That's
clever.
well, in Python, sadly, it is.
Oh, you're right.
But but let's
yeah.
assume that you know, the index, and I guess what, not -1. But I don't know. Binary search just returns true and false.
That's true. So we'll just do true and false.
Who cares? Okay, so what's binary search, Ben? What's binary search?
What is binary search? So binary search is what you do when you look up something in a dictionary, basically. So if you are looking up the word...
Not a Python dictionary. A real dictionary.
Oh, a real like, hey, look, dictionary. Remember those? Some of, you know, like they had the little dig outs on the side where you could, like, it would be labeled A, B, C, D, whatever. Not one of those, because then you would already know where to start. But say I was looking up the word murmurate, which is what starlings do when they flock together. So I'm looking up murmurate. I'd open the middle of the book, and if I found words with the letter L, I'd be like, oh, I need to go to the back half of the book, because that's where I open up. Then I take the back half of the book and I open it up middle way, and then there's like, oh, I find the word salubrious, and I'm like, oh, okay. So I'm gonna go. Well, M is before S, so I'm gonna go to now this little middle portion, and I keep cutting it in half and in half until finally I get down to like a page, and the page starts with mixture and ends with murder. Well, no, then it wouldn't be on the page. Damn. Mutt. It ends with mutt. So then I would look on the page and I would find murmurate, and I'd be very happy.
Oh,
so
God, you didn't make it easy for yourself.
I sure didn't, did I?
All right, so to explain this in kind of a more numbery sense, if we start with a list, and so here's the rule: the list must be sorted, right? Because Ben's little dictionary example is sorted. The phone book is sort of sorted, depending on various things. But if we have a sorted list, so we have 1, 2, 5, 8, 9, 13, 17, 22, right? And we say we want to search for, say 2. Something's in the list. So we're going to search for 2. So what we're going to do first is, instead of scanning the whole list, we're only going to check the middle elements. So how many elements are in this list? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So, okay, so that's an even number. So I'm going to add it so that, well, whatever. This is fine. So we're going to go to that number divided by 2. So 8 divided by 2 is 4. And so we'll look at element 4. So this is 0, 1, 2, 3, 4. And you will look at element 9. Right? And you say to yourself, okay, well, I don't know. I don't know anything about element. It's not element 9. But the good news is that I know that all of the elements that are less than 9 are to the left. So now I only have to search this part of the list here. So basically now I can just search this part of the list. My God.
My word. Why? Am I making a lot of noise? I'm sorry.
No, we're going to have to... Okay.
Oh my gosh.
So, and then, all right. And then here what we're going to do is...
If you want to inmodinate Cam and Patty G.
Okay. Yeah. All right, cool. So now, all right. So now you search through the list, and 4 divided by 2 is 2. So you'll take element 2, and so you know that 2 is less than that. So now you only have to search these 2 elements. And finally, which is good because we reached 215. This list has 2 elements. We search this element, and it's there. Yep, return true. So, but this is going to be a recursive function. So what it's going to do is it's going to return true up to here, which will then return whatever he said, return whatever she said, and then it's going to return whatever Zorblack said. And so basically, at every point, it's just going to bounce back and return all the way up the call stack to the top. And so that's how binary search works. So let's code it up really fast, and then we'll... or should we wait until next time, Ben?
Yeah, so we'll wait till next time.
Yeah, let's just wait till next time.
Also, it's a thinky time. Why does it... You guys ask yourself this question, why does the list need to be sorted?
Well...
Need to be sorted. Why can't we use an unsorted list? All right, so in our post time, are we ready to talk about something completely random?
If you'd like.
I think we should.
All right, let's play the...
Minecraft.
Hang on.
No, I've got a topic.
Hang on.
Well, actually, do you mind if I post a
Jesus
straw poll?
Christ, Ben. Hang on.
Do you...
I want to play the outro scene, man.
Oh God, yeah. But before the outro, one sec. Before the outro, I'm gonna post, if you don't mind, a straw poll that asks them whether they prefer this combined format or the individual lectures, and you know, we'll probably still do whatever our schedules permit, but it's good feedback. So,
all right, I'm doing the outro scene. We don't have to end the stream.
No, we're not. I just want to, before people, the outro says go away.
I just want to tell people that lecture is officially now over. And if you think that this is the most chaotic and nonsensical thing, you don't have to sit here.
Okay. Yeah, it's true. You don't. All right, now we're in the darkness. I feel more comfortable.
That's right. You see?
So I wanted to hear your thoughts. Rotary engines, like Wankel rotary engines.
I'm not sure. I think you've got me.
You don't... They're cool. Do you know, like, a normal piston engine, right?
Yeah.
So piston engines, they got the pistons. Rotary engines don't have any pistons in them. There's, like, this, like, triangle with, like, a circle. Like, it's a triangle, but it has arcs for sides.
A Wankel engine. It looks like it's one of those, kind of, it has to be one of those shapes where it's like a object of constant width.
Yeah. That's exactly what it is.
And so in order to operate properly, yeah, I think it's similar to a Rouleau triangle, which is an object of constant width. Yes.
Those are cool. You should go to like find a GIF or a YouTube video of what there's a 3-dimensional one.
Yeah. I mean, there's Rouleau
they're cool because they work because they're constant width. You can like roll them around and they behave like balls.
Yeah, I think this is gonna be a long video. What?
Oh yeah. I was behind. I had to hit the live thing. Oh, this is... Well, I want to see a real one though.
Yeah, hang on. I just want to be... Oh, a Rouleau tetrahedron. That's even better. That's kind of the name, right?
Yeah.
My God, I think we might have to...
Well, Patrick and Cam are doing the doing the work for us. But anyway, so the cool thing about the rotary engine is it has one of those in there, and then it like
I have found.
This is what I'm talking about. Yeah, look at that. They all behave like spheres, but they're not. Anyway, so one of these triangles is in this engine, and it like rolls around in the engine, and it does the like compression, exhaustion, and ignition phases in the space between the circle and the triangle. So
Mm-hmm.
like as it rolls around, when it gets close to one side, it compresses the air and it gets some fuel in there. And then when it gets real close to the wall, like on this picture, the bottom left, it's really close to the side, then it's mostly compressed. And then an igniter goes off and it like causes an explosion to force it to keep going around. And they are, I think they're really good engines for power mass ratio. Like,
Hmm.
and I think, but they're inefficient. They're bad fuel efficiency, but they're really good power mass ratio.
Are
So you
they
can
are they
get,
more inefficient because the pistons are of smaller mass than that giant thing that's like rotating around or something?
yeah, or I think that like there's certain engineering decisions they like the
Disadvantages.
exhausts
Oh
work.
wow, look at that.
Yeah,
Okay.
yeah.
Um.
But its advantages, to my mind, is a very good power mass ratio. I'm surprised they don't use them in more like because you would
Hmm.
get a lighter aircraft with the same horsepower, even though it would guzzle even more fuel.
Well, yeah, but I mean, fuel is very heavy too. So
Oh, that's true. That's true.
yeah, so it's a
So maybe it's
problem.
not a good trade-off for aircraft. There are a few aircraft that use these types of engines.
Hmm. Interesting. Yeah, I mean, I think I'd heard the term before, but I'd never really a Diamond DA20 with a Wankel engine.
Oh, that's right. The diamonds use them.
Yeah, apparently.
Wankel. Anyway, I thought that was a really cool way to use geometry to make like a very strange engine.
Yeah, I
And
mean,
and I knew you would get your it would you get your I'd get your math take on.
yeah, I mean, it's one of those things that you show it to me, and I think that pretty quickly I revert to I'm like, oh, that's one of those surfaces of constant width garbage. Um,
Oh, people
yeah,
were asking for a Minecraft server for the general student populace, and to that I say, I'm not gonna moderate that. It seems like a
yeah.
nightmare. We can't
It's,
even run a YouTube
well,
video.
we're getting better. I don't think we've had quite as much chaos on previous videos, honestly.
It's
There
yeah.
was a decided uptick on this one, which did not make me happy, but
I know, but that's okay.
I was
We have
hoping we could hide under the radar,
uh-huh.
and
Mm-hmm.
yeah, it's not entirely false.
Mm-hmm.
But the internet, there's some good things about the internet.
Yeah, like things
Yeah.
like
Well, Wikipedia's not bad.
I like Wikipedia. Yeah,
And our
they
lectures are
they're I think someone put it subpar.
was that one of our trolls, or
I don't know.
I think it might have been.
It might have been.
But honestly, what are you going to do?
What else? Is there anything else to say about life?
I don't know.
It's a troll.
What is the nature of the universe, Ben?
Uh, I think like really high quality caramel candies. That's
Uh, you see, I've got you. Let me see if I can
and
pull
it
it up.
got me. Me?
Yeah.
Is it a caramel candy? Or
Yep.
Here's a
caramel?
question you shouldn't be able to answer. Computer, what is the nature of the
Oh, I
universe?
see. I can't hear.
The universe is a spheroid region 705 meters in diameter.
Oh yeah, I remember this actually.
Great episode. Oh man. Anyway,
Yeah, we have Hero Cam. Cam's graduating though. I'm sad. We should pay respects in chat for Cam moving on.
I know
So
it's
sad.
well now that now that I vaguely know how to basically ban people, I guess I can ban everybody.
Yeah, make him have to slow him down. I have my LAs come sit. So
Yeah, I wasn't having that be done because I figured to myself, it probably didn't need to be done.
yeah. They also answer questions. They're just generally heroes. So,
Oh, you see, I just answer the questions in real time, dude. Since I have multiple monitors, I can just read.
You're just what? No. Hey, I'm gonna use a hip term. Weird flex, but okay.
Yeah, you are definitely way more, one
way
of these
more
kids these days.
with the
Yeah,
lingo.
like I don't know, man.
That's what I miss with the in-person lectures is I can say something like that and then someone will inevitably groan and it's great. I knew when I was a student there were professors who did that and I was like, why do they do that? Like it's dumb. And now that I've done it, I see it's a lot of fun.
You thought it was dumb? I knew it. Oh. No,
I thought
mean,
it was kind of dumb.
What?
Yeah, when I was
Nah, you don't understand. Trolling our students is all we got left, man.
Don't at me.
I really wish that there was like a groan meter on YouTube.
Yeah, we could rig something up.
Yeah, there should be something like that. I mean, I don't want a like or dislike button for the whole video. I want just like a real-time estimation of the level of groanitude of the students.
That sounds like an amazing tune. Actually.
Yeah. I mean, really, all you need is just like a dial widget, and it's like those stupid things that what's that guy's name? Those little when you watch those political debates, who's that guy? Frank Luntz, and he makes people turn the knobs, right? They're like, if you're happy, turn the knob.
Right. Yeah.
Yeah, and if you're unhappy, turn the knob in the other direction. And it can. I mean, I'm not sure if happiness can be expressed in a single dimension, but I guess Frank Luntz believes that it can. So,
all the dimensions of happiness.
Well, those are also the dimensions of misery, and misery is definitely hyperdimensional, right? There's at least 20 or 30 dimensions to misery.
Yeah. Also, this is sort of official course business, but some of you are still around. Stop cheating on assignments. Please. That's just my PSA.
Yeah, well, unfortunately, these guys aren't the guys.
Yeah, we got the high quality humans. So that's okay.
Or if they are, naughty humans.
No, but look
at what you've made us do.
People are learning hard lessons.
Oh, I'm learning the freaking hard lessons. I'm getting taught.
You're getting taught?
I'm getting schooled. It's painful, man.
Have you been cooking anything lately?
Who, me?
Do you just survive on Dorito dust?
Oh, what? No.
You eat the whole chip.
No. So, I have a can of beans a day. Okay. And, I don't even heat it. Because just like Rorschach says, find this way. So.
Yeah. So you just eat what kind of beans?
Standard baked beans.
Standard, okay.
Just like in Arma, right? You get dropped in with a pistol or a knife and a can of baked beans or something.
Yeah. That sounds good.
Where's
his can of beans? He doesn't throw his can of beans. He found maybe an empty. Debeaned it with his nutrition center.
Actually, I mean, I've been eating pretty well.
I feel like we should just do a lecture where we both talk like aliens that are trying to fit in. That might be how we already run it, but I think if we put a little more effort into it.
So, I want to share something with the students. I'm going to cue it up, so we can talk about other things, but yeah, just keep talking about other things right now.
Oh gosh, okay.
Yeah, hang on.
Oh, quick, Phil, we gotta fill time. No, we don't. Uh-oh. What else is there to talk about? Have I learned anything fun recently? Not really. Oh, I've been doing WebSockets. Those are fun.
Oh, yeah. I remember you saying something about that.
Yeah, they're not so bad. I originally thought that and they're only like
Ooh,
so
break
now I
it
can
up.
make web chats and games and things like that in the browser because I
Yeah, it really is awful though. Those things like that's one thing that I always wondered, and I still do wonder, is why JavaScript just doesn't have native support, like native true, no imports, just support for that kind of stuff.
for what sockets?
Yeah.
It does now.
Oh, it does now? Huh.
Yeah, that's what WebSockets are. Yep.
Oh.
And they're not the worst. It's like you make a WebSocket object and then
Well, yeah, I mean that's what you do with things.
shut up. And then yeah, it has a few function pointers you can give it for like
Screw this.
on create, on connect, on message, and then you can send messages to it. So it's pretty cool, actually.
Oh, it's season 2. Okay. Yeah,
Does
I mean,
distinguish from PyCharm copy paste. Yeah, we definitely have the ability to detect duplication from the internet or from each other. So don't do it. And it's really good. It's software that is developed. It's like 8 research papers from Stanford. Like it's anything that you can think of. There's actually been papers on how to defeat the software that we use, and the conclusion of the paper is the easiest way to defeat the software is to look at someone's code, then don't look at it, and then rewrite it all yourself. It's like, what? I mean, that's still cheating, but it's like you have to rewrite everything from memory, and it's a complex thing. Then it's not really defeatable.
I mean, I don't know. I'm not as compelling. I haven't looked at that paper, obviously. I think it could probably. I think it'd be easier. I think this is a statement. It's easier to, if you see someone else's code, to write code that is not technically cheating. No, is not technically cheating, but would definitely trigger it. But I think it is definitely harder to. Well, actually, I'm kind of curious if there's ways to kind of get around it. I'll run some experiments. I'll tell you guys exactly how to get around the cheat checker so that you can. But then, of course, if you do the things that I'm actually thinking of, your code would look so bizarre that
you're basically doing obfuscation.
Right, your code would look so bizarre that it would be kind of like
what are you doing?
I'd be like, oh, that's what I was saying in that lecture about making your code look funky.
I actually talked about obfuscation earlier this summer.
Oh, I didn't.
Have you seen the contest, right?
I mean, I know about the contest.
Yeah, the cool thing about the contest is that they tend to make like ask with their obfuscated code. And a lot of them, if you give the code as a file to the code, like if you run the code on itself, it will do something special as well. So I love it's like the nerdiest contest in the world.
Oh yeah.
Yeah, we don't talk about.
No, excellent. I found it. So, I don't know why I was thinking about this, but I'm always reminded of this one.
And justice, as you ate our children, so shall you be eaten by us.
Oh, I need
We will begin with the firemen, then the math teachers, and so on in that fashion until everyone is eaten.
Oh, I think I actually made a reference to that. So the point is that I always love Futurama because they always reference math teachers.
They always roast math teachers.
Well, yeah, more or less.
Do they praise math teachers?
Well, I mean, Lura was going to eat the math teachers after the firemen, but I was just pleased. I was very pleased that that math teachers were second on the list, and also it reminds me of like, the axiom of choice kind of stuff, where it's like, so yeah, I was very happy that in the I guess I shouldn't say axiom of choice, I should say well-ordering principle. So in the states that every non-empty set of positive numbers contains the least element. Yep. And in the well-ordering of occupations, math teacher is 2.
I like how, as a math person, you take a thing that has actual meaning and then you like put it into a juicer where like you're being more precise, but you've also robbed it of anything meaningful or fun. You're like, but I'm
Meaningful or fun. Damn, now I thought it was gonna be great, and then it was like a shift to the gut.
I don't mean that.
Oh, do you not? I think you mean exactly what you said. I think you mean exactly what you said.
I mean it a little bit.
Yeah. So.
A little bit. All right. Well, I think we done enough damage today. I think we.
I mean, in terms of actually not really teaching anything but pretending to. And then playing them an episode of Star Trek.
I think we did good. Everyone likes video day class.
Yeah, I wish I could do more of that in class, but we just don't have time. I noticed. I don't know if you noticed this, Ben, but do you notice that teaching on the internet is slower than teaching in person? Because I pretty uniformly get through less material on a daily basis.
Oh, maybe. It could go either way for me. I think
I don't know. To me, it's like slower, not by a factor of 2, maybe by a factor of, I don't know, like 1.25 to 1.5.
It's slower to me. I don't know why my poor get the short end of this, but I have real problems because I switch windows frequently in 341.
Yeah.
And I will just forget to switch the window in OBS, and then I will like
oh, so you
diagram.
Mean, oh, yeah, my students never screamed at me about that all the time. All the freaking time, guys. I know.
I almost wept on stream because I had gone for like 12 minutes. And I was really happy with my explanation. And I go back to the chat, and they're like, one student was like, I'm just going to go get lunch until he realizes what he's done. And I was like, I don't want to explain this again. It's really hard to explain. But yeah.
Oh, Cam says he's glad that he's glad I've tuned in the factor of slowness that I've introduced into my class.
Yeah, that's good. I don't know. It's kind of a mess.
But I mean, like,
somehow I got a whole week ahead in 291 from my schedule. I don't know how it happened.
How? Well, anyway.
I don't know. I guess they're just all really great and smart and stuff. I don't know.
Wow.
I don't know. But we're doing web apps. One of them's gonna be called "What's That Bridge?" And you're gonna put your location in, and it'll tell you the likely bridges that you're looking at, and that's all it does. Isn't that beautiful?
That is that is one of the most Ben type activities that I can possibly imagine.
Come up with it. I know.
Well, okay, so you might not have invented it, but you selected it, right?
Oh, I sure did. Well,
and
yeah,
I think the process of selection determines the nature of your reality.
It was I definitely nurtured it because one of the students was looking out the window during class, and I was like, "What do you?" And then like, it's a small class. There's like 7 students in it, and he says, kind of like wistfully, "What's that bridge?" Because you can see a bridge out in the distance. It's like, I wonder what that bridge is.
What's that bridge?
Yeah.
Wait,
so what's that
was this during a remote lecture, like an online lecture?
No, this was in person.
Okay, because I was confused. I was like, how could you see that the student wasn't looking out the window? Do you have secret cameras in all of their houses?
No. I don't want to see those things. No, but yeah. So there's that. But now I think if somebody doesn't have an idea, I think that would be a lot. You could create class sessions and then give students a button to click when they groan at something that you say, and you can watch your groan meter.
No, I think it should really be a dial. We should definitely just completely rip off Frank Luntz.
Okay, a dial. Okay.
Because that allows an expression of degree, right? If it's at 0, you're not groaning, but you're not cheering either. If it's at like +5 at groaning, right? That's like someone said, there's 10 kinds of people. Those people who understand binary, and I'm not even going to finish that joke, right?
Oh, Oh, also, I'm gonna plug since I'm here. I
Do
need to
it.
plug next time when we're 291, guys. It's being taught by the person who taught me everything I know about Python, James Stevenson, next semester. So if you're a non-major, meaning you're not a comp sci or a comp e major, you can take this class, and we go over stuff like web scraping, web development. We teach some of what you would learn in 202. And like a smattering of databases and machine learning. Basically, it's a cheese plate for upper level comp sci classes. The goal being to like kind of, if you're only going to take one more comp sci class, we try to cram as much useful stuff into your brain before we release you out into whatever your actual discipline is. Be it, we have mechanical engineers, biologists, chemists, all sorts of really smart, fun people in that class. And I'm teaching it this semester, and I'll probably be helping James teach it next semester. So definitely look out for that. If you have questions, shoot me an email about it. It's a fun class.
Did you mention that it's for non-majors only?
It is for non-majors, CS and Comp-E majors. You're going to get all this material eventually, for the most part.
What?
In your other classes.
No, they won't.
Yeah.
Don't lie to them, Ben.
So the projects thus far have been, we did Gridify, which was a spot, Cam grabbed Spotify data, and for the band Deadmau5, and the students had to make a little command line prompt that would read in that data and tell you album and song information about Deadmau5 things.
I think Nash has the right strategy.
What's
you just
that?
go and you change your major for one semester, and then you're not a CS major anymore, and then you take the class, and then you can flip back eventually.
I see. Yeah. Well, I have my lectures. A lot of them are online now, so if you want to kind of see what we're covering right now, you can. And we also go over like versioning and collaboration and things like that. So, why do I own a bulldozer? I inherited a bulldozer from my uncle, and it is very large. It's like 12 feet tall. I also have a backhoe. So, yes, I'm taking 341, 313, 331, 291 next semester.
That's an art major. Yeah, that's...
Yeah, I mean, I was a literature minor for like a year until I started getting bad grades because I was disagreeing with the professor. It's like, oh, I don't think I like this anymore. I can read books on my own time. So, yeah. Anyway, it's a fun class. Oh, another one of the projects was there's a Pokemon API online. And so students were asked to write a command line program that you send in 2 names of 2 Pokemon, and it goes to that API and it gets all of their stats. And then it generates an HTML file that has like the pictures of the Pokemon fighting, and then a little battle narrative. And extra credit was like if you used the type information about the Pokemon to determine the winner, or like help you determine the winner. So if you had like a water versus a lightning or whatever, or electric one, the lightning one would win. So that was project 3, I think. So they've been pretty fun. The most bland one was the one that's out now and due today. But yeah, it's a fun class. Yeah, there's this 291 channel. You can get all the projects. So, like a 1/4 a music major. And the professor who's teaching 291 is has a degree in musical composition from Peabody. So it just goes to show comp sci nerds come from all places. So, all right. Well, I guess we should go. We've run way over time.
Well, I mean, in a sense.
In a sense.
I mean, class has been over for 10,000 years.
10,000 years.
That's
so.
What's that from?
That's from my twisted brain. I don't know. I just said that. I say a lot of things.
I was thinking of never mind.
All right.
That's right. I mean, granted, we are the most useful people. We have if you did a well-ordering principle of useful people, we would be pretty high up there.
We would be of constant width.
Well, not quite yet, but yeah.
24 lectures, 24/7 lecture when We might do some like stuff over the summer for funsies. We'll rope you guys in on. We did a Twitch stream because there was much demand for it. Maybe we'll do that again. What do you think, Eric? Do you think we'll do it again?
Sure. We can play some more Homeworld.
Some more Homeworld. Yeah, I gotta get my chops.
Yeah.
Charity lecture stream. That would be fun, but hard to organize and probably, you know. But yeah.
I don't know if we should do charity. Oh God.
Who would we donate money to?
Well, really, the issue is like us taking dollars from people.
Yeah, but I think there's a way to like set it up so that like it's not really us doing it. It's like Twitch does it for us, and we just like pick like Doctors Without Borders or something.
Yeah, I mean that would be fine. I think. I mean, Medicine Sans Frontier or whatever.
Yeah, Médecins Sans Frontières.
You do the best French.
No, I don't. Oh, okay. I have to talk about this. So I have a friend who's German, and I asked him what Americans sound like in German, and he's like, "Well, what do you mean?" And I was like, "Well, so when Germans speak English, they kind of sound like somebody who's like unsatisfied with like the functionality of software because it's not precise enough, or it doesn't have the like the talk with." In English, and they don't sound. It's like, it's just language is not precise enough. And so he laughed at that, and then he's like, okay, I have to think about it. And he came back to me and he said, Americans speaking German sound like baby pigs. And I was like, piglets? And he goes, oh, that's the name. That's cute. And he's like, anyway, Americans speaking German sound like piglets in like a dusty area, not mud, just dust, and they're just rolling around in the dust, having a lot of fun with it. And he's like, that's what Americans speaking German sound like. That is the nicest thing I think anyone has ever said about Americans.
Hey, now. Well, then again, whatever. So, Ben,
Anyway.
did you drop? Oh no, you're still there. Okay. Right.
All right.
Should we
that's it.
terminate the
I gotta
stream?
go do other stuff.
Oh yeah, you think? Are you gonna join me
Yeah.
for my 203 class tonight?
Oh, yeah, maybe.
You
I
don't,
might
you don't
other
have
things.
to. You don't
No, I
have to.
want. Look. Hey, what did I call you earlier? Honey bear.
This is not. There's a difference
I want
between
to.
That which is desirable and that which is morally obligatory.
It's true. I have so much fun doing our co-lectures. So, I didn't look at the thing. Let's
I can
see.
tell.
What's the 79% of students prefer the combined format? So there you go.
Oh, did you actually give a poll?
Yeah, it was only 29 votes, but yeah, it seems like there were only 6 students.
Well, maybe
who
if we can
prefer
get our
it.
act together and improve the quality of the lectures slightly.
Yeah, we can get that number up,
Yeah.
I think it's mostly those 6 people feel that I have horribly tainted the magic of your stream.
Yeah, I'm sure that's the complaint.
It probably is.
I mean, granted, that we did distract each other quite a bit more than, I usually distract myself.
Yeah. All right.
Anyway, all right, I'm gonna let
Let's
you
do
go.
it.
Yeah, get out of here.
Thank you.
Get.
All right. Bye. Bye.
All right, everyone. That concludes this episode of Ben and Eric talk about sorting. Or I guess it should be Ben and Eric put things in order. Is this the last lecture? Yes. It is the only lecture. Okay.